Welcome to another video on my Raspberry Pi 2 right here, connected to serial cable, power by USB and network cable, as well as a band cable connected to this breadboard with some electronics. Raspberry Pi is running Raspbian, no Ubuntu Linux. Ubuntu Linux because I'm using the root operating system, which runs best on Ubuntu. Also, since recently, a smartphone stand with a fischertechnik, together with a motor fischertechnik with a propeller and a photo transistor and an LED. And this is built so I don't need to hold it in my hand when I'm lighting the photo transistor. The idea is to get a usable voltage out of either one of those pot meters, variable resistors, so I can get a positive signal right here through the cable, through the band cable, and only then I can make sure that things start to work, because the voltage is the problem, and that is a little bit hard to solve by now. So let's see how I can get it, because this one proved not to be the solution, and I have to improve this stand. So let's see how everything works out. Alright, a modification of this stand, and I will show you what it looks like now. So to keep it from toppling over, I moved the point from here to here. So now, without any problem, the flashlight of my smartphone is now right on top of there. Apart from that, I noticed that I do have a little problem with the speed, because it took a long time before this was actually running. The rest was remarkably faster. With the light active, you can see that there's a voltage. With this set to 5 volts, this is nowhere near 3 volts even. So let me change the scale to 2 volts. Now I need 1 first. Now this is really not what you want. Let's go back to 1. It's 1 volt. Not even 1 volt. So the full scale right here is not even reached. Let me take channel 2. Channel 2 is after the discrete division, and the third line, this one, is after the big potentiometer right here. It's not, so that's not even 1 volt. So I really need to find out how I can change it with a different potentiometer to enlarge it, to increase the signal value to 3 volts. And actually this was a recap because I did it last time as well, but now I know for sure. But how to do that? Do I have the equipment? Let's find out. Alright, reasoning some more. Light is right on, and I have added a probe to the input to the phototransistor. Input is 5 volts. So here you see 5 volts, and this is set to 5 volts, this is still to 2 volts. I changed the position a little bit of the phototransistor, so it now gets actually 2 volts. Or its output is 2 volts, which is not entirely what I expect, because looking at the schematics, it is 5 volts. A transistor is a digital switch, either on or off, by means of an electrical charge. A phototransistor is nothing different, except that the charge, the input charge, is dependent on light. Voltaic transistor, so it gets light and it switches to on, and its output is, instead of 0, it gives a high voltage, well, a voltage. So why is it then not 5 but 2 volts? That doesn't make sense to me. So let me switch it off. Everything goes down. I take off the cap. Back on. What's the result? 5 volts, of course. Although the question is this really 5 volts? It should be. Getting everything from right here. That should work. So let me now change the input of this channel to 5, which it says it is not 5 but 2.5 volts. So is it dissipating that much voltage? I don't know. So first thing is not to look at this one. Thing is to look at this one. Why does it give that much less voltage than the input? Very strange, in my opinion, but let's find out if my idea is right. Right, I have created another simulation in SciLab with a transistor and a switch, and from examples I managed to find a nice circuit. So a clock, a pulse input to the switch. The switch has to be on voltage 5 volt, and the battery pack, the voltage has to be connected to ground. The transistor has to be connected to voltage as well as to voltage measurement, which goes to graphics output, which is connected to a clock. Sounds nice. Unfortunately, as you can see here, this happens. So the question is why it happens, because there is no error as far as I can see. So this is being set to 5 volts. This has been set to amplitude 1, which I think is enough. Clock has been set to period of 1/10, whatever that is, and this is the same. It could be that this is the wrong transistor, but I don't think so. I can try, by the way. So let me pull up the toolbox. That is, where's the toolbox again? probably here somewhere. No. Okay, I have to find the toolbox and insert another one of this. Hopefully that will make sense. And with different transistor. So this is an NPN, this is PNP, very different type. But let's see if that is making more sense. Nope, it doesn't. Still errors on the same position. I've been trying to find how I can do that. Source code, but I have not found it yet. So unfortunately I can't tell how this is resulting in a nice graph, giving me some insight. Yeah, so this is almost a reality. The variable resistor that I have in here, which is here, pot meter variable resistor, I haven't used yet. But unless I find out how this is going to work out, not much chance. Right, despite these results, let me run the programs for ROS anyway. Control first. Yep. You can see the motor running, then fischertechnik LED, will it work anyway? I doubt it. So let me activate the smartphone for the light. And on the oscilloscope you can clearly see the change. 5 volts from the power, and then output, etc. from the phototransistor. I could do the red LED, of course. So this is a new terminal, so I have to make everything still at work. And then the red LED, which should start to blink now, which it does not. So now it, okay, that's a wiring issue. And that, as far as I can see, is the only thing I can do. With a few things remaining, as said, the voltage here, I can't find another element or component, unfortunately, and that's all there is for now. Hopefully I can find something with SciLab next time. Why it goes into error right now, I can't tell, unfortunately. So that's it for now. Thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Please leave a comment or suggestion, very much appreciated. You can also follow me via Instagram and Twitter. You can please support me by becoming a patron. Please visit my website for that, see under this video. And you can also support via PayPal and IBAN. More information, once again, see my website, my Patreon page, and also final segment with all information. This is going to be continued, of course. For now, have a nice day, take care, bye.